then we're good. So with this, if you want to pull that out first, so I give you a hard copy of like the exam review too, and then we'll just do these 4. I numbered them 1, 2, 3, 4, and then we'll just see how far we get. Alrighty. And then there should be some stuff. Like kind of in my head, we'll do these. I'll show you how to do these, and then you should be able to go back and do that stuff. Okay. So what we'll do. So all this is saying, like, if something says like solve for x, would you know how to like?
I need a little refresher. I know I did okay with this unit when we did it, so
okay.
I just need a little refresher.
So solving for x is just like I just want to get this by itself. Okay. So like, and then you kind of want to pivot around the equal sign. So you have 2 sides, right? You're gonna have like a left side. And that always has to equal the right side because that's what the equal sign's saying, right? So on the left side obviously looks a lot more complicated, right?
Mm-hmm.
So what you're gonna have to do is if I'm in like the boat of trying to get this by itself, then I can start manipulating the entire line here. Does that make sense? Kind of. I haven't done anything yet, but I'm just talking.
Yeah.
So the goal is to get x by itself. So why don't we take right now, the -3 here is just sitting by itself. So I could take it and move it to the other side. Right? You ever had to do that?
I think I'll use the way I did it from grade 8 because my other teacher did a little bit different. I think you do on this side you do +3.
Yeah.
And then
okay.
The other side. Yeah.
That's totally fine too. So that's the gist of it. Okay. So you can I'll do it in red. That's fine. We'll do it that way. So you can add 3 to both sides, and it's opposite because it's minus here, right? And so they basically, if you were to rewrite this out, you'd have 2x minus 3 plus 3 is equal to 7 plus 3. Yeah?
Yeah.
Okay.
That's how I was taught it for the basics.
That's fine. Yeah. So then -3 plus 3 is going to be 0, so they're going to wash out. And then so if you were to rewrite this, you'd have 2x is equal to 10.
So with this, I know some teachers have asked me to carry down the 7 plus 3, or can you just add it right away?
You can just do it, yeah.
Okay.
Yeah.
So 2x equals 10, and then take the 2x. No.
So remember the goal is just to get this by itself, right?
The x, yeah.
So is there a way, the question is there a way
put both those over 2?
Yeah, so these are attached, right? They're like, you can't, there's a way to untie them, but they're physically, you can't like add or subtract them now, right? Because they're attached to one another. So the question is there a way to like, to untie them?
You have to, with the 2x, you want to do over 2 because that cancels out 2 and 2. So that'll get x by itself. And then when you go over 10, it'll take it to the lowest common multiple.
Like that, right? So when I write something, or when anybody writes something like this is implying that they're multiplied together. Right? When they're like side by side.
Yeah.
Right? That's implying that they're multiplied. And so what you did here, you added 3 when you had to subtract 3. That's like the opposite, right? So adding and subtracting are opposites. So if you multiply,
you have to divide.
Divide is its opposite. Okay? So then these cancel now, and you're left with just x by itself. And then you're like, okay, well,
5. So x equals 5.
Done.
Perfect. I'll try to write that on my paper.
Sure. Or you could we could save time. I'll see if I can just post this after, and you can try the second one if you want.
Sure. I'll give this one a try here.
So try the second one, and then I'll post this, and then you can go watch it, and then if you want to fill it out, you can fill it out.
Okay.
But try the second one. The second one's a little trickier just because of the 0.5 sitting there.
Okay. I'll have to look at that for a little bit of a reference. I don't have a calculator, but I do have a phone.
Yeah, use your phone. Let's go ahead.
I guess that's 12. Let me do it again. Okay.
So you could do this. You could, like, let's say we didn't want to deal with decimals, and like most of the time we don't want to deal with decimals anyway. How would you write 0.5 as like a fraction?
1.5.
Yeah, one over 2, right?
Yeah.
So you could rewrite this as 1 over 2x plus 10 is equal to 16, right? And then we'll do what you did. We brought the 10 over. 1/2 x is equal to 16 minus 10. So 1/2 x is equal to 6. Now, what did we say earlier? What am I doing here? I guess these are still, yeah, okay, this might be a little trickier. These are still multiplied, right? But is there a way I could rewrite this the whole way down? Like if I were to multiply that, would you know how to like multiply fractions?
Oh man, yeah. Okay. So that would be x over 1, which would be
yeah.
X is like represents 1, doesn't it?
Yeah. Like that, right?
So it'd be it's just 1 over 1, which is still 1/2.
Okay. So like you're right with this, right? The x over 1 piece, but then you got the 1/2 over here, right? And when I'm multiplying fractions, I do the top times the top and the bottom times the bottom.
Oh, so it'd be 1x.
It'd be 1x
over 2.
Over 2. Now, what did we say earlier? If I'm dividing here, right? Like you don't even need that 1 there. It's like I'm dividing here, right?
And you're dividing the 6 by 2 because you have the x over 2.
Yeah. So if I'm dividing on one side, how would I like? What did we say was opposite of dividing?
Multiplication.
Yeah. So if I take both sides now, if I multiply both sides by 2, the 2's cancel. And what's your answer?
X equals 12. That's way easier to do.
Right.
That makes more sense, yeah.
So like sometimes the decimal, I don't like decimals, right? And a lot of teachers don't like the decimals because it starts to like, you get weird, like kids understand that. You know, like if you divide 6 by 0.5, they can't contextualize. Like they're confused by 12.
Yeah,
you know what I mean?
I was like, that doesn't make sense.
That's what I mean.
But, yeah.
Like you have to think about it. There's no thinking, right? You just throw it in there and then it's done. Now, my next question would be, how do I know I'm right?
You could do a check, which x equals 12, which you'd fill in with the x.
Yeah, perfect.
So you sub it in.
Right. So you'd have 1/2 times 12 plus 10. What should that equal?
Well, it should equal 16.
Yeah, exactly. That's it. So half of 12 is going to be 6 plus 10 is equal to 16. So then you know you're right. 16 is equal to 16.
That was correct.
Yeah, that's how you know.
Perfect.
That makes sense?
That makes sense, yeah.
Okay.
So whenever I get a decimal, just try and figure out
what the fraction is. You could do that. Or, yeah, sometimes you might not. Like something like, this is why we like fractions, because for you to represent, let's say if you typed in 1 divided by 3.
0.33.
That goes on forever, right?
Yeah.
So what's going to happen is if you write 0.333, even if you did 10 threes, you'd still have like a rounding error as the question went on, right? So you might be a little bit off. That's why we use the 1/3, right? Because I get an exact answer with the fraction, right? When I bring it up and I multiply by 3, I get an exact number. If you were to like divide that by 0.333, you'd get like just a slightly number off. Does that make sense?
Yeah.
So like I guess the point is like sometimes like you might get like a decimal number that's like 0.175, then you're kind of stuck, right? Like I wouldn't worry about it then. But if you can like come up with it right away, like 0.5, I just write 1 over 2.
Alrighty.
Or you could use your calculator too. You could do what you did before, just to get the answer with the whatever it was. So there's 12 divided by, or 6 divided by 0.5. You can do that too.
Alrighty.
So then the next thing I have here, this was like kind of like a proportion statement. So it's kind of like words, not quite like the top part. We'll see some more questions on the next, like number 2, with like word problems. But this is kind of like a proportion statement. And the way I kind of handle these is like any word problem really. I like read through it and then I go, okay, I'm gonna read right to the period and then I'm gonna stop, and then I'm gonna try to like take out information that has been said to me, right? And then I write it out. So suppose the claim is that 6 out of 7 dentists recommend Colgate toothpaste. Okay, so like you got a fraction, 6 out of 7 dentists, right? The question is, if 91 dentists are surveyed, then approximately how many of them would you expect to recommend Colgate? So like every 7 dentists that they ask, 6 of them recommend it, basically, right? So you have like, you could go like this. Where X is like what you want to know, right? It's like how many of them would recommend it. So what you could do, this is just me, like, it's not necessarily the easiest thing to like figure out, but it's just the proportion statement. So it's like 6 out of 7, right? Is this part. How many of them out of 91 of them would like actually recommend?
So that makes sense, yeah.
Does that make sense?
Yeah.
So like what I'm doing is like, here's like the pros, how many, not pros, but like how many people are actually like recommending Colgate. You want to know on this side also how many would actually like recommend from 91 dentists, right? So then you like, now you're in the position you can solve, right? Have you ever cross multiplied?
Oh, yes, I have, yeah.
So all you got to do now is just cross multiply, get rid of the fractions. So you're just going to go 6 times 91 is equal to 7 times X.
So that's how you write if you do cross multiplication, that's how you write it. Because normally, like what my older teachers would do is you try and cross it out and find the lowest common multiple and then multiply it. But,
do they kind of reduce it?
Yeah, but you can't really reduce that.
Yeah, like 7 and 91, I don't think it really goes too well, right?
Yeah.
So this is just like, this is me eliminating the fractions. So now now we just have one line.
Which is better than fractions.
Yeah, yeah. So that's what cross multiplying does for you. So anytime you have like an equal sign, you can like cross, and fractions on either side, you can cross multiply them just to get rid of them, right? And so then you're left with, okay, well, we're in the same position as the top part. What do I want to know? I want to know X, right? So how do I get X by itself?
Most multiplications you're going to have to divide.
Divide by 7 on both sides.
Now at this point, would you combine that 7x and then do that 6 times 91 with the actual number?
Yeah, you can actually do the math now. So these are going to cancel, right? Because when you do 7 divided by 7, it's 1.
Yeah.
So X is equal to, you can do the math on that now. So 6 times 91. It's 546, and then divide that by 7.
78.
So that means 78 dentists recommend. I don't know how many C's are here. That's like your first step. Does that make sense?
That makes sense.
So a lot of the work and like the thought process goes in up here, right? Then it's just this.
Just filling
up
in
top.
Filling in the numbers.
You're just solving for X now, right? Does that make sense?
It does. Yeah.
Okay. So let's go down here. So we'll do some word problems now. Okay. So this will be like the second one.
So I'm going to solve it on the back then?
You can, yeah. We could draw, like I just put that there in case we decide to graph it. Number 3, I found number 3. So like we can actually do the graphing question. I just put it there in case you needed it. So like this is just kind of like in a box, like how to actually attack these questions. So Nick opens a savings account with $50, okay, and then each week after he deposits $15. In how many weeks will he have saved $500?
Sorry, I gotta read that again.
That's okay.
So we're trying to find out how many weeks. So if I'll go to the first period, like you said.
Okay, sure.
With $50, so we'll put that down.
Okay, so we're gonna write. Okay, so it wants you to like kind of underline. I don't know. You don't have to do it this way. This is kind of like sequential for you to like. Like sometimes like kids struggle with, I don't know what to do first, right? And so like you go, okay, well, what's the important information here? We got $50. He's inputting $50 in the beginning, right? And then each week after that, he deposits 15 every week after, right? So then in how many weeks will you have saved 500? Okay. It wants to know how many weeks.
So I'm so bad with word problems. This is one of my weaker suits. So like I don't do well with word problems.
And like that's not uncommon. Like a lot of kids struggle with this. So typically I would say like if you could see, I see the word week quite a bit, right? So I'm like, okay, well, sometimes this might actually help. So maybe I'll do this. Okay, we'll skip number 2 and we'll come down here to number 3 first. Okay, because this is how my head works. I'm like, I don't know. I wouldn't know how to like write a let statement either. Like what the variable is going to be, right? So I'm just going to write the equation and then you can come back here and come up with your let statement. And your let statement basically lets you, at the very end, you know how up here we wrote the therefore statement?
Yeah.
Your let statement will allow you to like write that. That's what it's for at the end. So why don't we write the equation first, okay? And like when you see word problems, this is where you're gonna see where like after the periods, this is where it's gonna like come into useful, okay? When you write the equation. So Nick opens, in your head, you want to be thinking how much money's in the account after each piece of information, right? That's what you're thinking about. You're like, okay, well, it's going to give me something. How much is in the account, right? And so when you write the equation, you're going to go, okay, well, Nick opens a savings account with $50. How much money is in the account?
$50.
Okay, 50. Okay, let's keep reading. Each week after, he deposits $15. Okay, so it's going to increase, which means I'm adding, and it's increasing by how much?
15 each week.
15 each week. Right. In how many weeks will he have saved $500? Okay.
So what you want is like, it's kind of like up top where you want the left side equal to the right side? Or,
yeah. So you want an equal sign.
And then 500 on that side.
Okay. Now what's the only thing we're missing?
An X.
So where's it going to go? Does this ever? It's going on the thing that's changing. Does this ever change?
That changes, yeah.
The 50? Does that ever change? Like he does it once and then that's it.
Yeah, and then he keeps.
And then he keeps putting it in, right? So, but how much does he put in every time?
$15. That's what changes. Is the $15.
Right. So now you're like, does this make sense? How we arrived at that? So like that's where like drawing the bars at the periods helps a ton. So you're able to actually create the equation, right? Now we can come back here. What does the variable represent?
Let X equal. I don't know how you'd word that. Like.
Well, what's it every week, each week? And how many weeks? Let X represent the number of weeks he's depositing money, I would say.
That makes sense, yeah.
Does that make sense? Because that's what it's asking about. How many weeks will it take him to reach $500, right? Number of weeks it takes him okay. So it's pretty like, that's the way my head works too. I would come up with the equation and then go back and fill in the let statement.
Which makes sense, and it
Right.
seems a bit easier than just trying to throw it all into one.
Yeah, I think too many times it gets like, okay, write the let statement, and like you can't even do that. So then you're like flustered and you can't even get to the equation, right? What's the point of the question? We're trying to solve an equation. So if you can't get to the equation,
You can't solve it.
you can't solve it, right? So that I would just start at step 3, right? And then you can contextualize what's going on here with the let statement. That's all it's doing for you. It's just keeping track of what this variable is representing, right? That's all this is doing. Okay, so I would say now, is this any different than what we did up here?
Doesn't look much different.
Okay, so now we're just, forget about the dentist question, okay? The only thing that's changed from like page 1 to page 2 is now I've actually like put a meaning to X, right? This actually means something now, right? We can like answer a question. That's all that's changed. There's just some words down here. Okay, I still have an equation. I'm going to solve it. So let's solve the equation. What are we going to do?
So you're gonna want to rewrite the equation.
Okay.
Just to get it. Are we gonna solve it? Try and solve it up here, or where?
I'll do it down in like the step 4 area.
Okay. So you're gonna want to get x by itself.
Yeah.
And probably get that 50 over to the
Okay.
right side.
Do that always, right? So just get that over. So you want to write 15x is equal to 500. What do you want?
Minus 50.
You can go. Sorry, yeah, you're right. You're gonna go minus 50 from both sides, right? That's how you want to write it. So you get minus 50 over here.
So then it would be 15x equals 450. You put 15, like both of them over 15, and cross it the two 15s on the left side, so that x equals.
So I'll show you a little trick, because this is like math. This is like, and this works all the time. It doesn't matter if this is 45,000, 45 million, doesn't matter, right? What you can do.
Is it 30?
Yeah, it is 30. But so the way in my head, ignore that the zero's there. How many times is 15 going to 45?
3.
And then add the 0.
That's what
There you go.
I was thinking.
That's it.
Perfect. So then it's x equals 30.
Okay. Now
Put it back into the
you can check.
equation.
You can check. Yeah. You
It's
can
always
check
good
and
to
make
do
sure
a
it's
check.
good. Sometimes they get pretty big. Eh? Like you can go 50 plus 15 times 30 should equal what?
Well, it should equal 500.
Yeah, should equal. So you go, okay, well, what's 15 times 30? I don't know. 300, 450, right? So all I did was the 30 times 10, which is 300, and then another half, which is 150. So that's 450 plus 50 is 500. You can use your calculator too. But.
Yeah, I could probably, with these kind of questions, I could probably just do that in my head.
So the only thing I would like caution you of, and like I would maybe make a mistake sometimes too, in like the mental, like I might forget to do something. You know what I mean? So it's always okay to check it with the calculator. But if you've done this here, like this is your checking area, right? So it's 500 equals 500, right?
So it's correct.
So we're good, right? Because that's what it's telling me it has to equal. So your answer, therefore, you can write down here. This is where your let statement comes in. What did we solve for?
How many, like, the number of weeks it takes to reach $500.
Yeah. So therefore, it will take
30 weeks.
Yeah.
To raise $500.
That's it, right? The nice thing about lines is they're very like well, they're 2-dimensional, but like they just continue or they go negative. You know what I mean? Like there's nothing too fancy about those. There's some quadratic stuff that you would have done that's a little more complicated, but the lines are like pretty straightforward. You input something, you get something else out in kind of an equal amount all the time. That's what a line is.
It's like a pattern.
Yeah, it's a pattern, which we'll show you. I'll show you what the pattern is or how we figure out the pattern after. Do you want to try this one? Or do you want to like...
I'll give it a shot.
There's three in there.
Oh.
That's okay. We can do the second one.
Second. Okay. Try this one. Show all of them. I guess we'll do it on here too.
Yeah.
So, I'll just read the question on here. I'll break it up like we did last time.
Start down at step 3. All right, so draw your lines and then write your equation. You don't even have to read the question at first, right? You can just kind of look at the numbers, right, and deduce from it what the equation's going to be.
Let's see if I can get, so it would be 18, I'm just reading it off that. It says plus, if you're correct, 18 plus 0.12.
Mm-hmm. Right, that's what it's saying to do.
Alex wants to spend exactly $30. How many miles can he drive? So, he wants 30. And we're trying to figure out how many miles he can drive with $30.
Right, so at the moment, you just have numbers on your page, right? So you have nothing to solve for.
So we want to make it kind of useful. So
you're going to want to put a letter in there somewhere, a variable.
So charges $18 plus $12 per mile. So I'm saying the $12 are $0.12 per mile or whatever.
Yeah. See that word per?
Per.
If you ever see the word per, it's like, this is what it's saying, $0.12 per kilometer or something, right? If you see that word per, that's where the letter goes.
All right.
Right.
So that's where our X would be.
Yeah. Now you just solve it.
So it'd just be like any.
You can leave that. So when you're dealing with money, like decimals make sense with money, right?
Because kind of exact.
It's exact amounts, right? So we know what 0.12 is. That's 12 cents. So that means something, right? So we can actually leave that the way it is and just solve the equation that way.
Alrighty.
Okay, so you're just doing the exact same thing we just did.
So we're gonna minus 18 on that side and minus 18 on that side. Wait, I'll just write the next steps down on the.
Mm-hmm. You do yours, and then we'll compare answers at the end. I'll write this down.
All right. Okay, so that is. Oh, actually, that's right. My mental math is not on point right now.
Mine's not too good either.
Bit rusty. I was way off.
I'd have to use a calculator on that one too. So just write your let statement up front. Or
I forgot the let statement here. Oh boy.
That's tedious, but I think it's like a check. Like it's like one of these boxes that you have to check off when the teacher marks it, right? So you have your let statement. Like it's just something you have to do. this is probably honestly the easiest way to do it. Like write the equation, you solve it, and then like in your head, you already kind of know what the solution means, and then you write the therefore statement. That's like advanced, right? You just kind of do that. Like I don't think people sit around like when they're solving word problems and write let statements for the variables. Like actually, I shouldn't say that. Sometimes when we get a little more complicated, like in some of these other ones, when you have two of them and they both mean something, then you write let statement. That's where let statements keep things in order, so you don't mix them up. But these kind of things, it's just practice to get to that other stage. You know what I mean?
Yeah.
As long as we know what we're doing right now, the let statements are that big of a deal for questions like this. But when we start mixing like x's and y's in the same question, that's when it becomes important because you don't want to mix them up. You know what I mean?
So x. Question, I was just doing that. $30. And then the Air Force too.
There you go. Right? Like these are actually like everybody's like, where am I going to use this? But like even like in the next question, you'll see like an actual legitimate issue that people have to come up with like in their head. They're going to make a decision, right? But even like a lot of time with these questions, I'll use like rental companies, right? Like I know he's driving a car here, right? But like if he wants to save money, and it might not be a lot, but it might be a lot depending on how far he drives.
Mm-hmm.
He's gonna maybe have to pick between two different companies, right? And maybe the other company is only gonna charge them 10 cents per mile. So every mile they drive, they save 2 cents. How much is that gonna add up?
If you're going a far distance,
that's what I mean.
Yeah,
that's what I mean. So like, that's like an exact like at some point in most people's lives they're gonna rent a vehicle, right? And like you're gonna want to spend the least amount of money. So we'll see an example like with the cell phone problem. It's very, very similar. And you're going to want to pick the company that fits your situation. You know what I mean? That's what we're building towards. Does that make sense? I think you got it. Like, I think there's not much to that now.
Yeah.
You just need to be stepped through it, right, in a way that makes sense. Okay.
So we're on the next.
Yeah. So I'm just reading through this. If you want to do this one, we can do this one. This one's a little bit different. It's the exact same idea. It's a twist in the way you set up the question.
I always throw curveballs.
Yeah.
Well, we can try this one.
Okay.
Give it a shot.
It's just a little twist. We don't have to solve it all the way. We'll set up the equation because I think you can solve the equation at this point.
From there.
But it's a little bit different the way we set up the equation.
Sure.
Guys, just draw your lines. That's good. That's a good start.
So the bike costs $29. This is 24 more than 3 times. So wordy.
I know, that's what it said.
24 more than 3 times. And what she saved last month.
Okay,
Would you divide that by?
I'm thinking, yeah. There's some. I think this time we got a fraction in here.
Okay. Like,
so what doesn't change? For sure, you got it nailed, right? Like we know how much the bike costs, so we get to write 129, and that's equal to something. Okay, nothing fancy. It's equal to $129. Now, this is $24 more than 3 times what she saved last month. maybe this is a little tricky actually. This is a tricky one. So the 129 is $24 more than what she saved last month.
So minus
120, or sorry, 124.
So it'd be 105.
Yeah, but it's equal to
times 3 or 3. This is where my brain just shuts down.
okay. So like this got me too, and I had to think about this one, right? Because it's not like you get used to doing questions in this kind of way, right? And then they throw a curveball at you, but the idea is the exact same. Okay, so you're gonna have to like you've got your 129, and then the question says that it's $24 more than what she saved last month, right? Right. So you're okay with this part?
This. Yes, no, I'm good with that part.
Okay.
That makes sense.
So like, obviously this one's just asking like, how much did she save last month, right? Well, it turns out that this dollar amount that's sitting here is 3 times as much than what she saved last month. Okay, so I'm seeing the word month come up a lot, right? And I'm reading it a lot. So I'm thinking, okay, well, I'm going to say let X represent the number of months. Or sorry. It's the amount of money saved in 1 month. Does that make sense?
Yeah.
Okay, so then what you could do is like, all you're doing when you read these word problems is you're basically taking the numbers and then just kind of taking specific words and getting rid of the rest. Like there's just jargon in here, right? Like who cares what their name is? Like who cares what they're buying? Like it's just jargon, right? Just trying to throw you a wrench. It doesn't matter. What's important is that something costs $129, right? And then this was $24 more than what she was able to save last month. And that was 3 times what she saved. 3 times.
Because we don't know what she saved.
We don't know what she saves.
Okay, that just clicked in my head.
That's what we're trying to solve for, right? So that's what our let statement is. And then that's ultimately where you're going to say, okay, well, at the very end, you're going to, therefore, she was able to save this much per month, or last month.
So this is why, because X is already on it by itself. I could probably do that.
Yeah,
but
so you just do the math now, right? You just go, okay, 129 minus 24.
105.
Okay. And then you divide that by, I don't know if that goes in evenly. Divide by 3, right?
And then just you get your X.
You get your X. That's it.
And then I like checking it. I need to plug it back into the...
Right, yeah. Just to make sure it's good. That's a good habit. Right. Is that good?
Yeah.
If you want to do that, you can do it or you can not do it. It doesn't matter. You've done 5 or 6 of them now. I think you're good, right? Yeah. Do you want to go to the cell phone problem?
Why not? I'm here to learn. We'll learn this now.
Okay.
It opens. I don't know why I was trying to
slide. Yeah. I just found that downstairs, so I just keep it organized.
Awesome. I brought this, but I don't have any foil paper, so I brought like a really big paper.
That's what I printed some stuff out on.
The big paper.
Yeah. When we do like test reviews and stuff, like they were all on like huge papers. The kids in the last room and like, okay, awesome. It was like 2 of these wide, right?
That's pretty big. Okay, so we're on this one now.
Yeah. Okay, so this might take us the rest of the time. Okay, maybe not. And then I'll show you. So if we're good with this, then there's one other thing that we can do later, next week or whatever. This is like the hardest thing from this section. If you can do this, that's it.
And this is like slope of the...
This is slope and like slope, y-intercept, and like point of intersection. Remember doing all that?
I did pretty good in that.
Okay.
Like, not pretty good. I did better. I didn't fail that unit.
Right. That's like the hardest thing from like this particular question. Using this method is the hardest thing you're going to do from this section. Okay. So, but nothing changes from what we're talking about here, right? Like everything that we've done so far.
Keep that format.
You keep it like in your head because it's useful. Like it actually provides meaning to why you're doing what you're doing. Right? That's it. So with this is the step just before this. Okay. So with this this is what I was getting at with the 2 car companies, right? And this is 100% applicable, right? Everyone's like, oh, well, when am I going to use lines, right? Okay, you're going to buy a cell phone, okay? Now, sometimes, like, you can get unlimited minutes and stuff like that, right? But they can charge you. You're going to get charged your, like, normal. We could change this question to be, like, a data overage, right? Something like that, right? It doesn't have to be, like, calling on the phone because most people don't do that now. Like, they just text, right? So this could be, like, T could represent the amount of data used. Okay, we could change this question. Okay, and the number on the end is how much you pay per month. Okay, so does that make sense? So, like, let's say in the first question, like the call a lot plan, right? This guy here, right? Let's just say, for instance, 20. You're gonna pay $20 for your phone per month, and then if you go over on your data, they're going to charge you 50 cents per meg or something like that. That makes sense?
Yeah.
So for the purposes of what we're doing, okay, we're not going to actually do that because the question's already written the way the question's written. But we're going to take a step back here now, and it's just going to say, okay, I'm going to charge $20 per month, and then they're going to charge me 50 cents for every minute of long distance that I use. Okay? That's it. So, and then you've got, that's call a lot like plan. Now, this is what I was getting at. Sometimes you can make a decision based on your scenario, right? So, talk more plan, they're going to charge you $25 per month.
But with a lower
long distance time, right? So this is where you're gonna sit down and do this and figure out, okay, am I gonna like talk on the phone, or am I gonna go over on my data, or like whatever? If I'm not, then I'm gonna pick one company over the other. That's what this is answering for you. Okay. So there's an easy way to do this, more time consuming, and not the best way to do it. This is the best way to do it. Okay. Because I'm interested in one point only. It's the break even point between both companies. That's what I'm interested in. But this is just the way to do it. It'll always work, and it'll always work for every. It doesn't matter if it's a line or like a parabola. It doesn't matter. This always works. This method. It just takes way more time, and it's not the most efficient. So what you do is this call a lot plan. You can see this here, right? What I'm going to do is I have what are called like, this is like it's like a function machine. We call these things. Okay. Mm-hmm. So I have like red will be your inputs. Okay. Red are your inputs. Okay. And we'll make yellow your outputs. Does that make sense? So what's happening here is I'm going to input values for T that are specified here, and I'm going to get outputs on the other end. That's what's going to go in this column. That makes sense?
Yeah. So
what you're going to do, you're just going to fill this in. So 0.5 times 0. Do you want me to write this once so you can see what's happening?
Yeah.
So you're going to go 0. The cost, C, right? I'm just filling in numbers in this column. It's 0.5 multiplied by T. In this case, it's 0 plus 20. What's that going to equal?
0.5 plus 20, which is...
Okay, careful, because this is like, these are multiplied together, right? What's 0.5 times 0?
0. So it's just 20 then. Okay, so alright, I see what you did there.
Okay. Now, let's do it again. Except this time, just remember this is T. These are my inputs here. Right? I'm going to input 5 this time. What's half of 5?
2.5?
Plus 20.
22.5. And you just keep
doing it. You keep doing it, and like you can see how this is like, it's effective. It's going to give you an answer, but I'm going to have to do this twice, and then I'm going to have to plot the graph You know what I mean? And then I'm gonna have to figure out what this is ultimately. That's what I'm after. But you see, this is you would never do this, right? You want to write these two equations like what I showed you how to do on 1 and 2, and then solve them using this, right? That's what we'll build towards. Okay, we'll do it this way just so you can see, and like you're gonna have to do this anyway, right? They're gonna make you do this regardless. If you know how to do the other method, they're gonna make you graph it. So I'll show it to you anyway. Okay, so you're just gonna keep going, and actually you might catch on to a pattern, right? That's hopefully the idea.
That's what I was gonna ask. So like, how you can kind of start seeing a pattern by the third one, maybe?
Yeah. So what's this one gonna be? So if I input 10 here,
We're going up by 2.5 each time. It would be 25, and then
so before we go any further, you said going up by 2.5 each. What is this? What is this phrase?
is it like a let statement?
Kind of. Not
It's a
really.
pattern.
It's a pattern. Okay. It's another word for it, which is what else? What other like math words do you know? Around lines.
It's the slope. Oh,
It's the
slope. I was just about to say that.
The slope.
Because I was looking at the 2.5, and I could go eyeball the like if
Slope. It's up 1 over 2. Right? Or sorry, up 2 over 1. No. Up 1 over 2. It's half. Okay? So you keep going. Now you can go, okay, well, you don't even have to type this in now, right? You know the pattern. You've done it 3 times. So the next one's going to be 27.5.
29. Oh,
29? Or is it 30?
30. And just keep following that. So it'll be 32.5 and 35 and then so on.
Okay, so now you can go here. I'm going to highlight this and we'll do something obnoxious like pink. Okay, I'm going to start plotting these on the graph. Okay, they're points. You have an input, you have an output. Okay, now most of the time you have like an independent variable and a dependent variable. Okay, the independent one is just a fancy word for x and y. You've seen this before, right?
Yeah.
X is what you input to the equation. Y is what you get out. Does that make sense? So what did I input? All the t values,
yeah.
Right? So that just means time's going to go on this axis, right?
Oh, I guess you're doing it on there.
Yeah, you can do that after. And then on the y-axis is what you get out, right? So the cost. Okay. So then, do you know how to plot points? You've done this? Okay. So then you're just plotting these points. You're going to go 0, 20. I'll do these in pink because that
can't really see
them. Yeah. So 0 and 20, right? And then I'll go 5 and 2.5, or 22.5. It's tough to see. Is that it there? I can't really tell. And then you could skip, you don't have to do them all. You can go to 30. We'll go find 30 down here. And then go up to 35. Is it clear on your page? You can see the numbers a bit better?
Yeah.
Yeah, okay. So 30 and then 35 is it right at the top?
Top right, yeah.
Right? So you actually don't need the rest of these. You can plot them, but you don't necessarily need them. That's your line. So it was a little bit off with this other one. Okay, now, the nice thing about this now, this line represents something, right? It's like an infinite number of data points across here, right? So like I could go up. I could go find. Okay, well, maybe I'm not going to talk on the phone for 30 minutes. Talk on it for 29. You'll find 29. It'll tell you how much it'll cost you, right? The line is like an extension of this table. You have a whole bunch of data points there now, right? So that's what the line's doing for you. And then we can do the other one. You want to do the other one quickly?
Yeah.
So that this is all in pink. We'll do the other one in I don't know, whatever color. But same idea, right? I'm going to maybe do 2 or 3 or 4 of them, get the pattern, and then I can fill out the rest of the table, right?
No, since that's 0.5 and that goes up by 5, 0.25, would that go up by 0.25, or would that go up by a different number?
It's going up by 0.25.
Okay. Just because this one doesn't have decimals on it, that's the only thing.
Yeah. So what I would do if I were to do the table, I would just copy. You want an exact comparison, okay? But it doesn't really matter what you input into there, right? It doesn't matter. So it wouldn't have mattered if I inputted 29 and 20 and 7. I still would have gotten the line, right? It doesn't matter what I put in there. The equation is the equation. It's going to give you a line, the same line. So you could, for your sake of sanity, do points that you can do in your head. So I might do 0, I might do 10, I might do 20. You know what I mean?
By 10 kind of thing?
You could.
And then see the pattern.
Because you don't really want to do 0.25 of 5. Because I don't know how to do that. And if you're going to kind of get a weird number. Right? The point is that you can get the line. Okay? Even the 30. Okay? Does that make sense?
Yeah.
So then you could go, okay, well, I know what 0, this is going to be 25, right? 10 is going to be 30, right?
I guess just 0.25, yeah.
Yeah, so we're going to go C is equal to 0.25 times 10 plus 25. I might have been off. You're right. So 0.25 times 10 is just 2.5, right?
Yeah.
Do you remember how to do this? So if you see this is how our entire kilometers, centimeters, do you remember doing all this conversions? That's our entire measurement system is based off of this. So it's if I had 0.25 and I wanted to multiply by 10, I'd move the decimal to the right one because there's 1 0. So it'd be 2.5.
So each 0, you move it to the right.
Right.
Okay.
If you're multiplying. If you're dividing, you go to the left. So
because it goes down.
Yeah. So if I did 0.25 divided by 10, I'd move. Oh, sorry, 2.5. I wanted to do 2.5.
Then you move it one place to the left.
Okay. Just the number of zeros.
All right.
This is a quick you multiply by 1,000,000, you move it to the right 6. Right? There's 6 zeros.
Perfect.
That's how you would convert from kilometers to meters, right? There's 1,000 kilometers. Or sorry, 1,000 meters. 1 kilometer. So the whole system is based off of base 10. Right?
It makes it simpler.
It does. It's way easier than miles and inches, and it's just silly. Right? So what about, that's if I did 10, right? So then that was going to equal, what did we say, 27.5?
That's what, yeah.
Right? That'll be that one. And then 20, if I do 0.25 of 20, 1/4 of 20 would be 5, 10, 15, 20, right? So 5. So 5 plus 5, 25 is going to be 30. That should be good, right? You're going up by 2.5 here again.
Because there's only 30 points.
Yeah.
Really.
Okay. So your slope is 0.25. And your slope here in this one is 0.5. Okay. So what you could do this, or you could recognize the pattern, like what we were talking about, right? We could do this one with the pattern. What's our starting value?
25.
Right. That's our starting value because it's time equals 0. Right? Does that make sense?
Yeah.
right? Now what you can do, is there a way for me to write 0.25 as a fraction? Do you remember doing this earlier?
It'd be a quarter.
Yeah.
So it'd be 1 over 4.
That's your slope.
Which is there's a rise in run, so a rise of 1 and a run of 4.
Yeah. So just go up 1 over 4. 1, 2, 3, 4. You don't even need to fill out the table.
You can just keep going up and up and up until you get the line.
Yeah. Up 1 over 4. 1, 2, 3, 4. Up 1 over 4. It's hard to do my iPad. But it makes sense now. Like these two lines are going to collide, right?
Because it shows that there's less cost with the blue one.
Yeah.
It's going across.
There's more cost initially. And then when it crosses, it'll be cheaper, right? Because remember, the higher you go on here, the more expensive it is, right? But the lower you are, the less expensive it is. So we did this whole line. Up 1, 1, 2, 3, 4. Up 1.
The cross is right there. That's right.
So we call that like the point of intersection. Remember doing that?
Yes.
Okay. So this is why we care about this, right? It's at this point, right here, that we get to make a decision, right? We're at 20 minutes. So after 20 minutes, right? And like I've gotten ahead here, you could go back here after and answer each of these questions. We can talk about it next week. But like after 20 minutes, the costs are the same. Does that make sense?
Yeah.
So it's like now you have a decision to make, right? You're like, okay, well, if I'm going to talk now, a typical question on a test for me would be, what company would you choose if you were going to talk 26 minutes on your phone?
Probably Talk More.
Okay, which one's Talk? The other part, should have labeled these a little bit better. It's Talk More. Which one? Yeah.
Which is the blue one?
Why?
Well, because after 20 minutes it gets cheaper.
Okay, so this is, yeah, you're completely right. This is how I would explain it. 20 minutes. What did I say? 26 minutes?
20 minutes.
20 minutes is the break-even point.
Yeah.
So after 26 minutes, like I said, you're going to go to 26 minutes, and your decision or your answer to that question, which one would you choose, will be the graph that you hit when you look up. So I'm going to go, okay, I'm at 26. Which graph am I going to hit first?
That blue one.
The blue one.
Which is that's one.
That's what I want. So what if I said, okay, well, if I was only going to talk 8 minutes on the phone?
Then you'd want the call a lot more.
Yeah,
which is
because I'm going to hit it first.
Right.
That's where it's useful. There you go. Does that make sense? Helpful?
That makes sense.
Okay. So we'll stop here. The nice thing is we can